in this video. Hello everybody and welcome to the 70th video on this channel, which is another advanced geometry / advanced trigonometry video, but it is a little different. So that's about all I can say. Please make sure to like, subscribe, and hit that notification button. And let's move on to the examples this time. For today, instead of explaining a concept, we're actually going to be doing 2 examples. And the reason we're doing these examples is because proving something is almost like solving a problem, except you just know the start and finish. So showing you a few examples on how the proofs are, on how the different formulas are used, can help you just generally problem solve and will help you with creating proofs on your own. So let's move on to just solving these examples. For the first one, we have angle alpha is equal to 60 degrees, angle beta is equal to 30 degrees, A is equal to 12, and we need to find out what the side B is. Now, A and B are 2 sides of a triangle, and I'll give you another hint. A is opposite to angle A. So if we had a triangle like this, this would be side A and this would be angle alpha, as they're exactly opposite from each other. The same thing goes for side B and angle beta, because they're opposite from each other as well. So I'll give you a second to solve the problem. If you need to pause the video, you can definitely pause the video. And yeah, so I assumed you paused the video, and I assume you also tried to solve the problem, and let's go over the solution ourselves. So what we need to use for this is the law of sines. Now the law of sines states that side A over sine of an angle alpha is equal to B, side B over sine of an angle beta is equal to C over sine of an angle gamma. Now there is no C part because we never defined that, so it's just A over sine alpha is equal to B over sine beta. So what we have to do right here is plug all the values in. Now A is 12, so 12 divided by sine 60 degrees is equal to B divided by sine 30 degrees. Now, when we bring this over here, we get 12 times sine 30 degrees divided by sine 60 degrees is equal to B. Now, sine of 30 degrees is equal to 1 by 2, so we have 12 times 1/2, and then sine 60 degrees is equal to the square root of 3 over 2. But since it's in the denominator, it's going to be 2 divided by the square root of 3. Now, when you start simplifying this, this becomes, these 2 cancel, so that means you have 12 over the square root of 3 is equal to B. And that is your answer. If you want to show that, if you want to make sure that you're correct, you can always plug it back in. So 12 over sine 60 degrees is equal to 12 over the square root of 3 times sine 30 degrees. Now these 2 are the same, and so what happens is we're left with square root of 3 times sine 30 degrees is equal to the sine of 60 degrees. Now the sine of 60 degrees is the square root of 3 over 2, but the sine of 30 degrees is 1 by 2. So when we multiply square root of 3 and 1 by 2, it becomes a square root of 3 over 2. So that proves that our solution is correct. Now it's time to solve our second problem. Tangent theta squared plus secant theta squared plus 1, and you're taking the whole root of that. Now this is a little more complicated, and I wanted to show this because this kind of utilizes multiple theorems. So, and I'll also show you 2 ways to solve this. Both of them lead to the same answer and are quite similar, but one of the methods you might find slightly more convenient, and one of the methods you might find are a little longer or more annoying for your certain mind. Now, everyone's different and everyone has different ways of doing things, so I want to show you 2 different ways. Now, let's move on to actually solving the problem. The first step that you should always take when solving these types of problems, and when you see there's no cosine or sine, is always make it into cosine and sine, as those are really easy to manipulate and they have a lot of properties. So, tangent squared theta is sine squared theta over cosine squared theta, and secant squared theta is 1 plus cosine squared theta, and then you have plus 1. Now, the reason I'm not taking the square root is I'm going to take it at the end. But you could always add the square root on there if you tend to forget or miss that type step, because, of course, the answers will be different. So, now, what we have to do is you can see the first 2 terms have a common denominator. So, what we do is we combine them. So, sine squared theta plus 1 over cosine squared theta over cosine squared theta. 1 is now our new thing. Now, for this, what we can do is with the 1, we can create a common denominator so we can add those 2 terms up. So, sine squared theta plus 1 over cosine squared theta plus cosine squared theta over cosine squared theta, which is equal to 1. So when you combine these terms, you have sine squared theta plus 1 plus cosine squared theta, all divided by cosine squared theta. Now, what you have to do here is you have to recognize that sine squared theta plus cosine squared theta is equal to 1. So this becomes 1 plus 1 over cosine squared theta. Now this becomes 2 over cosine squared theta. Now, you can't forget to take the square root. So, when you take the square root, this becomes the square root of 2 divided by cosine theta. Now, that's about how you solve it. Now, there is one method which takes a slightly different approach to it, and you might find that easier or you might find that more confusing. So, this method involves using tangent squared theta and 1. Now, tangent squared theta plus 1 is actually equal to secant squared theta. So this becomes secant squared theta plus secant squared theta. And this becomes 2 secant squared theta when you add these 2 together. Now, what you have to do is after you take the square root, this becomes the square root of 2 secant theta, which is the same answer as the square root of 2 over cosine squared theta. So that's about it to solving both of those problems. Thank you so much. See you in the next one, and bye-bye.